Hello friends, welcome back to our channel. So today we'll see one more concept in computer networks, that is congestion, and also we'll see the principles of congestion. So let us start the session with the definition of congestion. What exactly it means? Congestion means having a more number of packets in the network which goes beyond the maximum capacity. So having more packets in a network beyond maximum capacity, okay. So just an example for this congestion is a traffic jam. Okay, if more number of vehicles try to travel on the same road, automatically there will be a traffic jam, and that kind of traffic jam we call it as a congestion in networks. So heavy packets, overloaded packets will be there in the bandwidth. So what is the main cause, or what is the impact if a congestion occurs in the network? What is an impact? So obviously one is there will be a lot of delay, right? So imagine that you are traveling from one place to another place, and suddenly in the middle there is a heavy traffic jam. Obviously it will take more time to reach the destination, so there will be a delay to reach the destination. The same thing here also. The first impact is delay, more delay. Okay, so obviously there will be some sort of delay, but there will be more delay, so we can write it as increased delay, to reach the destination. Okay, to reach the destination. And the second one, loss of a packet loss can also be done with a congestion. Whenever the congestion occurs, the automatically packet loss may also happens, and then automatically throughput. If there is an increase in delay, there will be less throughput. So at particular time period, how many packets have been transmitted successfully to the destination is a throughput. So automatically it will be reduced because of increased delay. So these are all different impacts. Okay, different impacts. Now we will see the principles of this congestion. So simply just remember, congestion means a traffic jam. So packets, traffic jam of packets over the network. So let us see the principles of this congestion. Principles. So the first principle, prevention. So prevention means before the congestion occurs, we need to prevent the congestion. So we need to design the network so that the prevention should not occur, right? So design a network that avoids congestion. So how it happens means, so more bandwidth, using a more bandwidth, and using the buffers in the routers, buffer size in routers, increasing the buffer size. Okay, increasing the buffer size, right? So by using all this, and also routing algorithms, using efficient routing algorithms, we have seen a lot of algorithms, right? So by using these efficient routing algorithms also, we can prevent the congestion while designing the network itself. Okay, so that is the first principle. Next one is detection. Detect early. That means once the congestion occurs, so how fast we are able to detect the congestion. So that is very important. So how fast we can detect congestion once it occurs. So that means in the first principle we are seeing, so congestion, how to avoid getting the congestion, and second one, already if congestion occurs, how fast we can detect the congestion. And the next one, feedback mechanism. So this is also, once the congestion occurs, so how it can be detected and how it can be sent to the sender, because the sender will be sending the packets continuously. So regarding the information about the congestion, it should be clearly delivered to the sender itself. Sender have to know that there is a congestion in the network, right? So sender should know about congestion once it was occurred. So there are two types of feedback mechanisms. So one is a implicit feedback. So what is implicit means, so based upon few information, the sender will be knowing that there is a congestion in the network. So what happens, so based on delay, packet loss. So these are a few informations. Based upon these data, okay, based upon the delay and packet loss, the sender will came to know that there is a congestion. And another one is explicit. So here the name itself indicates explicit means the nearest router where the congestion occurs, that router have to send the feedback to the sender knowing that there is a congestion. So the routers send a choke packet, or control packet to sender to know about the congestion. Okay, so these are the two feedback mechanisms. So first one prevention, second one detection, and the third one, after detecting, how far we can send the information to the sender, right? Next, I'm erasing this one. Next, so once the packet or once the information is sent to the receiver, so receiver have to, sender, so the sender have to reduce the transmission rate. So if the sender is keep on sending the packets to the network, automatically the congestion will be more and the packets will be lost, because the routers can't handle all the packets. So some of the packets will be lost. So in order to avoid that, reduce transmission rate. So once sender came to know about congestion, automatically the transmission rate should be reduced. Transmission rate should be reduced. So obviously then the data will be, the congestion will be slowly vanish out. And the next one, fairness, that's also more important. So many senders or many users can send the data or packets to the network, so the bandwidth should be clearly organized to all the users. So bandwidth should be equally utilized to all users. Okay, so we should not give the complete bandwidth to only particular user. So all the users should use the bandwidth equally. So that is more important, fairness. And the last one, the last principle, adaptability. Adaptability. So what is this adaptability? That means dynamically the allocation will be changed. Okay, so if network is, I mean, the number of packets are more, what should we do? Transmission rate should be decreased. That means if the number of packets means nothing but a traffic over the network. If the traffic over the network is more, automatically the transmission rate should be decreased. Okay, and similarly, if the number of packets over a network are less, that means if the traffic is very less, automatically the transmission rate can be increased. The process can be increased to reach the destination. So dynamically it have to change. Okay, so whether the transmission rate should be increased or decreased based upon the traffic over the network. So this is the called as a adaptability. So all these are the principles. Okay, prevention, detection, feedback mechanism, reduce the transmission rate, fairness, and adaptability. And congestion means heavy load over the network, so which beyond the maximum capacity, right? So that is called as a congestion, and example, the traffic jam. Okay, so hope you got an idea about what exactly means the congestion, right? And in our next session we'll go with the congestion control techniques. There are two control techniques, open loop and closed loop, so which we have seen in our principles like prevention, detection. So those two techniques are open loop and closed loop. So in our next session we'll discuss about that congestion control techniques. So if you are having any doubts regarding this one, feel free to post your doubts in the comment section. I definitely will try to clarify all your doubts. And if you feel our session is useful, so like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.